when f sub c is equal to f, that's a 1. 1 minus 1 is 0, and the denominator gives you infinity. So at each cutoff frequency here, let's say I'm going to do the 1-0 mode first. I have lambda here is equal to infinity, and when f goes so high, this becomes small, and that approaches 1 and becomes lambda u. So that's your lambda u. I have that kind of situation. That's lambda 1-0 guided. If I go to the next mode, each mode will do the same exact thing. I don't have to draw it for every mode. I'm going to do it for this mode. Again, it will be infinity here, and it will come down to asymptotically to lambda u. Lambda u is equal to what? C phase u bar by f. Right? Lambda f is equal to c. Right? Lambda times f is equal to c. That's a known expression. So if your wavelength without the guide is 10 centimeters, inside the guide is going to be long. Always. So we conclude that lambda guide is greater than lambda u. That's the first thing that we conclude. And if you recall the diagram that we did a couple of weeks ago for the two waves that were going at an angle, and so the wavelength in the guide, you will find it greater than the wavelength, the original wavelength of the waves without the guide. That's the first one. Second one here, which is going to require us to have a bit more discussion here, is the phase velocity inside the guide. C phase Mn in the guide. The phase velocity for each wave is going to be what? It's going to be omega over beta. So I take this beta and do omega over beta. This is omega right there. So omega over beta is 1 over mu epsilon under the square root, 1 over square root of 1 minus f sub c mn over f whole squared. And this was C phase unguided. So we conclude that C phase Mn guided is equal to C phase Mn unguided divided by the square root of Fc Mn over F whole squared. The same exact plot that we have over there, except I'm going to change the labels. So if I write this as C phase Mn guide, I write this one here as C phase Mn unguided, I'll have the same exact diagram. So based on that, I conclude that C phase Mn guided is greater than C phase Mn unguided. So not only the wavelength is faster, not only the wavelength is longer inside the guide, but also the phase velocity is faster than phase velocity in an unguided situation. This should wake you up to a very serious conclusion here. Can anything be faster than the speed of light? We just proved it. We just proved that we can have a phase velocity inside the guide. Assume epsilon and mu are those in free space. 3 times 10 to the 8 meter per second. Right there, 3 times 10 to the 8 meter per second. Divide by that gives you 4. 10 to the 8 meter per second. As simple as that. Well, there's a physical explanation for that, and I've been trying different things over the years, and I have a paragraph on this in the notes on the waveguide. I think that's the last section that you will see, last page. And shall I let you read it and enjoy it on your own, or shall we explain it here? Okay, I'll try to explain differently here, all right? Basically, the phase velocity is an apparent velocity. It's not something that is moving at that velocity. Later on, we'll get the information velocity and the power velocity, and we'll discover that they are less than the speed of light. Right? If you're sending information or sending power, they will definitely be slower than the speed of light. But the phase velocity is an apparent velocity. And the easiest way to explain it is the example I'm giving in the notes. Actually, you can do it with your own hands like this, right? Imagine that I put my arms like this, and this one here is on the top, and this one here is on the bottom, all right? And then I flip the situation on. And you are monitoring now where the top exists. Here, the top was here at this location. Now the top exists here at that location. Now, can we claim that the top moved from here to there, and the time I moved my arms? Yes. Right? The top, which is the peak phase, right, moved from this spot to that spot in the time I moved my arm. I can move my arms fast or slow, and this top here would have a completely different velocity unrelated to it. Simply, I can increase it by increasing the distance between my arms, and I can decrease it that way, the velocity of moving the top. All right? While the same physical velocity of my arms haven't changed. Right? Velocity of top moving here is slow, here is fast. Here is faster. Right? So you can see now it's an apparent velocity. It's not anything that has moved at that velocity. It's just the phase disappear from here and appear over there. Okay? Just like magicians, all right? They don't really move things. They tell you, look over there, something else came up there, right? Nothing moved from here to there. It's just an apparent velocity. So this is the magical, right? Phase velocity that is faster than speed. I think that's a good point to stop, especially with my throat hurting. And you need to think about this phase velocity thing as well. And if you have any questions before we go.
Is that like saying that the magnitude of potential can change faster than the speed of light, but not move faster than the speed of light?
No. No. Nothing is changing faster than the speed of light. Nothing. Even the magnitude. It's an apparent thing. It just disappeared here and appeared over there.
They just all happen to be changing the same speed, and it just looks like it.
The speed here is the same. I haven't changed that. By just, extending the wavelength, all right? I can just see a faster appearance of the...
It's a relative speed.
I hate to give it any of these terminologies. It's an apparent thing. Right? And the example of the magician is really the right thing to say regarding this.
It's the resultant of two velocities. It's the resultant of two velocities. That's why it's a current.
I can't hear you
It
well.
is the resultant of two velocity vectors.
Uh-huh.
So that's why it looks like it's moving faster.
Maybe you can send me that, I still can't hear you well. Send me an email. Right. Just, I know you go into some philosophical things sometimes, so I appreciate it. I'm just teasing. We worked together last semester, he was my GPA, and we had some good times, so. What is it that I wanted to say? Yeah, when you see the groove velocity, all right, that is going to be less than the speed of light, and we'll explain that physically. It has physical meaning. The speed of light, the phase velocity, the best explanation to it is just exactly what I said here. It's an apparent velocity that it could be deceptive, but mathematically, it's a velocity. Right. I'll see you Monday.